All right, so let's do another section here. So, secure operating system and software architecture. You got the kernel. This is the heart of the OS running in ring 0. And there are two types of kernel, monolithic and microkernel. The monolithic kernel is one static executable file. The whole kernel runs in what's called supervisor mode, and everything has to be pre-compiled in. So if you want to add a new feature, you have to recompile the kernel. And this, I think, is what Slack did. You have to recompile the kernel to add a new piece of hardware or anything. This is faster, but less secure against crashes. And Unix and Linux, it says, uses monolithic kernels, although there are loadable kernel modules, so I'm not quite sure how that works, but a microkernel is smaller. Yeah. Apparently they do. So this, I guess the loadable kernel modules are allowed too, because you don't have to recompile it all the time.
Which operating system uses a monolithic?
Unix and Linux, because the alternative is microkernel, and Windows is a hybrid system closer to a monolithic kernel, but including things of both. So here you have a smaller system, and this is the one where you have loadable kernel modules. And I'm afraid what's really used is not as simple as being in either of these categories 100%. This is generally the case. You have these simplified models, and what we really have is more complicated. Windows apparently mixes the two. So this is slower, but more secure against crashes. Anyway, the reference monitor we talked about, this is the security feature that mitigates all access between subjects and objects, so it checks to see if you're obeying the security policy. You cannot bypass it, and you have secure systems can evaluate the security of the reference monitor, and you must have this to achieve level A or B of the TCSEC model. So in Linux and Unix, you have read, write, and execute permissions. So you have an object like this header file is owned by root, and the root has read, write, but not execute permissions, and people in the group have read only, and other people have read only. So you have these 9 bits that determine what permissions are available. That's the Linux system. In the Microsoft permission, you have a more complicated setup with these things: full control, modify, read and execute, read, write, and special permissions. And those apply to groups like everyone, interactive, administrators, system, and so on. So it's more complicated and not as simple at all as the Linux permission. And by the way, these are only of approximation. There are actually 14 binary permissions that are gathered into groups to make these containers. In the Microsoft system, it's far more complicated and confusing. All right, there are special programs in the Linux kernel that elevate to root. A set UID file has a special permission, so a program owned by root can be executed by somebody who is not root, and when they execute it, that program runs as root. This is necessary, for example, to change your password. To change your password, you have to change the system file that stores the passwords, and nobody has permission to do that except root, so a normal user changing their own password has to be elevated to root briefly to make that change. And the old-fashioned way to do this in Linux was as a set UID file. So that was password. Now the problem with these, it tends to create a vulnerability, because if you can make it crash while the permission is high, that's a privilege escalation vulnerability, and there have been a ton of those, where you take these files and you find a way to trick it into giving you extra functionality in the elevated mode. All right, then there's virtualization. We talked about virtualization is a program that simulates hardware, and then you install an operating system on the simulated hardware. That's VMware and VirtualBox and so on. Full virtualization is where you simulate hardware which can be totally different than the actual system hardware. Para-virtualization is where the virtual hardware must be similar to the real hardware, and therefore it runs faster and is simpler, but it means you can't have completely different hardware in the virtual machine. All right, and so the hypervisor is the software that controls the connection between the guest operating system and the host hardware. So a type 1 hypervisor runs directly on the host, and that's what VMware's ESXi is. It's just a thin operating system just to support virtual machines. You can't actually use the ESXi itself to do anything else. You can't install like Microsoft Word on ESXi. You just have to install operating systems on it and then run those virtual machines. Type 2 is what you use in this class like VMware Workstation, where it's actually an application running on an OS, and then it stimulates hardware, you can put another OS on it, so you can run a Linux virtual machine on a Windows host operating system. So the point of virtualization is, in a data center, you can now have lower hardware costs because before virtualization, most data center hardware was only running at like 20% efficiency, because you'd buy a server and run a process and it wasn't really, so then by virtualizing it, you could now add multiple virtual machines to it and push it up to using more of it. You also could mix different hardware, but have the same virtual hardware, so your cluster would work, even though the underlying hardware was not the same, which happened because you would buy a bunch of servers and then time would pass and the new servers are faster and better and cheaper. So you'd like to add more servers that are not the same hardware as the first one and have them interoperate in a cluster. And you can do that if you make virtual machines and all the virtual hardware is the same. So that's the sort of thing. Snapshots are useful for backup and recovery of virtual machines. And we talked about this. Clustering guests can be much simpler than clustering real hardware servers, where you really have to make all the hardware exactly the same. So there's other issues. If you run many guests on one host, then they're not perfectly separated. If somebody exploits one of the guests, they might take over the host and move over and take over the other guests. So you shouldn't be running guests with different security requirements on the same host because of VM escape attacks. VM escapes are exploits that escape the virtual machine and take over the host, and those do happen now and then. There's also, blinded by virtualization, if you try to monitor your network, then you can watch the network traffic leaving the host, but if one virtual machine is sending network traffic to another virtual machine, that never actually goes out onto a network adapter and you won't see it. So this is a problem. There will be virtual traffic going through the virtual NICs that you can't see by monitoring the physical NIC.
So there you can also cannot see the virtual machine to the host then?
You can if you put an agent on the virtual machine. You could do something like have Velociraptor and install a Velociraptor agent on the virtual machine, and then you could see it. But yeah, it is an issue. You have to consider it. All right. And so there's under cloud computing, of course, three general categories: infrastructure as a service, where you're like renting the hardware, and you can, or virtual hardware, you can just install stuff on it; a platform; and then software as a service. This is where you have complete control over it. You have to install your own operating system, your own updates and everything. Here's where you have an operating system and you can do some configuration of the software. And here's where you're just using software somebody else gave you, like Gmail, and you can't modify anything. You just can use the features they give you. So that's the game. You can make a private cloud where it runs on your hardware in your data center, and it's a cloud just because it's accessible from various locations, or a public cloud, what most people do, like Google, Amazon Web Services, where it's a server machines running that somebody else is controlling, you don't even know where they are, and so on. So this is cheaper and more common, but of course, you've got a problem if you're putting confidential data on there, like health data or military data, and Amazon and Azure, over the past several years, have worked really hard to have special programs to handle military classified data and protected data like health information. They have a more expensive plan where they promise that the data will always stay in the United States and that it meets certain security regulations. So they have special plans for sensitive data. They did that in order to vote for the JEDI contract. The US military made a huge bid for put military data on cloud services, and Amazon and Azure both worked hard to meet the specifications so they could guarantee the security requirements for that. I think it got hung up in court and canceled, and they're trying it again. But the government did want to put classified data on cloud services.
No, they end up splitting it up into three.
They ended up what?
Split it up.
Yeah, they ended up multi-cloud, yeah.
Into three and they all get in.
Yeah, and yeah. Anyway, so, yeah.
So if I have a regular cloud service,
Yeah.
but I set up something on my side to make sure that everything is encrypted when it goes to the cloud and decrypted when it comes back to me, is that, well, I'm guessing that's not an acceptable solution. Why not?
Well, that is one solution. You could have, if you have your own key and you encrypt everything, like you can use Dropbox. You put stuff in Dropbox, it goes up to their server. If you encrypted it with your own key, then that would mean Dropbox can't lose it, and you would then have to decide. If you're going to try, if you were doing like PCI compliance, I think that would be acceptable. It's just that's why complying to a regulation is not a simple cut or dried matter. You have to be examined and audited. And then you would have to say, my cloud provider is not running the special PCI compliant version, but I've added my own compensating control to add that. And if you can convince the compliance auditor, you'll be in compliance. That's the issue. You don't have to do it just one way. You have to either do it the normal way, or you have to have some explanation of how whatever you've done is as good. Yeah, you can have custom stuff.
No, I was wondering why no one did. I guess it was just too complicated in practice.
Well, yeah, most companies, the reason is technical debt. This is why they wouldn't let me code when I started working at a bank. If you let somebody do something like that, then what happens 5 years from now when they've left and you have other people running the company? And what happens when you merge with another bank? It turns out just doing the standard thing that everybody does is usually the best business decision in the long run. That way, you can hire people, everybody understands it. Yeah. Anyway, so, yeah, and here's some,
Replaceable worker is best.
what's that?
Replaceable worker is best.
Yeah, that's right, yeah. Anyways, here's some questions. How does VM escape work? Well, you have to find, one common VM escape is if you have shared folders with the host, which some people turn on, then you can actually access like the documents folder on the host from the virtual machine. And you could put malware in there, and sometimes you can even launch a process on the host, and that happens in containers. There are ways to launch a process on the host from the guest. Yeah, and so this is a question, a very good question. Is there a separation between the host and the virtual machine? And there is a separation, but it's not a complete perfect separation. There's an attempt to keep them separate, but obviously there's some communication there, and when there are bugs, there will be a chance of exploiting it. And so it happens every now and then.
VM machine is running at minus, right? Host minus, right? Break minus.
Minus?
Remember the VM machine is running at
Well, yeah, ring -1 means it has the ability to directly access the hardware. That's right, which doesn't necessarily mean that it can take over the host, but it does suggest that it has the privilege to take over the host, and the guardrails might be overcomable. Yeah, that's right. So anyway, another thing happened, by the way. Amazon, when they started, Amazon had a bunch of machines you could download and use that were donated by users. They just had like a users area where people would just put up machines. You could download a machine with like Drupal configured on it or something. And then people put up machines that had like a backdoor on them, or machines that were just clones all with the same SSH key. And so if you got these public cloud machines, you would get machines that weren't very safe. Just like if you install Firefox extensions, they're written by random people and some of them are not safe. So that was an issue. And then there's grid computing is another system where you combine machines that are different hardware and even different operating systems all to work together on something like SETI at home or folding at home. You can arrange to make a cluster of non-identical machines working on the same problem, but that's of course requires some careful coding. Right, so parallel systems give high performance, but they share memory between systems. And this means you can have race conditions where one process changes something and another process reads the same thing that was changed by a different process. So you have brief moments of vulnerability. That's what race conditions are, or when by getting in first, you can change something and have an unexpected result. And that's commonly how those privilege escalation exploits work. Then there's peer-to-peer networking like BitTorrent, where a bunch of machines share data from one to another over the systems. And it's decentralized. There is no central server with the master copy, so you can't take them down by taking down the central server. And so the main point of them is to distribute illegal content like stolen copies of movies and music, and you don't have one central server to take it down. Someone says, is there any open source platform to create a private cloud? Yes, there is. There's a bunch of them. There's one to make data file storage, OpenVAS, I think. I forget the name. There's there's a file server. Yeah, there are ones. I don't know the name of it though. I've heard of them. There are various ways to make your own private cloud. You can use a lot of people just use ESXi and Microsoft Hypervisor, but you can do it a lot of other ways too.
Isn't your private cloud is also open source?
You can do it with open source or closed source. You can use.
What do you use?
Oh, what I use? I use. Yeah, that special Linux distribution, that is open source. I forget the name of it. Let me bring it up here. pc.samsclass.info. Proxmox, that's it. Yeah, Proxmox is what I use. That's right. Proxmox, that's right. Good question. Proxmox is one, and I'll throw this in the chat. If you want to make a simple private cloud, use Proxmox. Proxmox is a Linux-based distribution, in fact, Debian-based, and it makes it easy to start up a server and share those machines over the cloud. Thank you. That's one. There's a lot of others, but that's one. So the peer-to-peer networking, what it does is you download a file from a bunch of other people that are running BitTorrent, and you get fragments of the file, and each fragment has a hash value for integrity, so you can combine pieces from all these different machines and get a file with the integrity being verified. The problem is you have no trusting in the source. It's all stolen material, so some people steal a movie and then add malware to it and then put it up, and then all the hash means is you get the malware without the malware being altered. That's the problem. When you're getting stolen material, you can't trust the source, so it's ultimately a supply chain insecurity issue. Then there's thin clients. This is what I'm using in my consulting gig. This is very common now. Not everybody's working at home in the pandemic. You could send them a company-owned laptop, but what's better is to just give them like an Azure virtual machine in the cloud. Then they just connect with a VMware client, and all the data and all the programs are in the cloud under the company's control. And so you can't, it doesn't matter if their home machine is stolen or infected with malware or anything. The data is on the company machine in a separate machine. It's a very nice idea. And then there's diskless workstations. They have these sometimes where you'd have workstations in a room and they don't even have a disk. All they have is a network card, and they connect to a cloud machine. So you don't have any local storage in the room. That way you can't get infected with malware, or nobody can take the data away or anything. It's just a hardware version of the same thing as the thin clients here.
How is it different from the thin client?
It's the same thing essentially. A thin client is software running on a machine to connect to it. This is special hardware that can only connect to it. That's all. It's a way to make these desktop things cheaper. We had a lab set up this way, and the students were not happy because there was no way to save their files and take them home. So it's pretty annoying. But that's, of course, a feature. And my consulting gigs, that's the whole point. I can't get any files and take them home. I can't put any files up there. All I can do is connect and use their applications on their server, on their data, and that way they can say nobody took the data.
They just want you to contribute, and then they keep everything, own everything.
That's right, they own everything too, yeah.
I think the difference is that the thin client does not think at all. And
Yep.
the diskless workstation doesn't have to remember anything, but it does some thinking. It can process it.
Well, sure, but the thin client also does some processing. It's a program. It's VMware Hyper something that we run. You run a program, and it connects to the cloud server.
Basically, the example I gave, if I type an A and an A appears on the screen,
Yeah.
does it need to ask the server for the A to appear? I think for a thin client, yes, but for diskless, no.
Well, I don't think in modern days, even for thin client, that was really in the old days. That was terminal host model in the old days. Yeah, these days it's not that clear, not that big a separation. Yeah. Anyway, all right. And then there's the Internet of Things, of course. All of our smart light bulbs and thermostats and cars and everything are all now computers, and everything's connected to the internet, and very many of them have terrible security with default passwords, and the server storing your data on unsecured cloud storage. And, as everybody knows, it's kind of crazy, the Internet of Things. Everything's now a computer, and a lot of it is not secure. So there are an endless series of exploits infecting these devices and stealing the data from them, and so on. All right. Let's take a look at 3D. Yeah, see, thin clients are newer and diskless workstations are older. Yeah, that sounds right too. All right. Although these things keep going around. I mean, in the early days, you had terminal server because there were no workstations. All you had was IBM servers. When I started in the 70s, there was one IBM mainframe, and that was it. And everything was just a phone connection terminal because that's all they had. Then they invented the local workstations and put everything on there. Now they have versions of going back to a weak workstation and a powerful cloud. We rock back and forth to these various versions for various reasons. Anyway, let's look at 3D. Yep. All right. Hello, Frosty. I'll start up Zoom to help people right after these cahoots here. Zoom while I'm waiting. All right, had 9 last time. I'll wait a few more seconds. Maybe we're only going to have 8 this time. All right. All right, so what do you have to have for TC-SEC level A? You have to have a reference monitor. All right, so which one is a security problem with virtual machines? That's VM escape, when malware on the virtual machine escapes and infects the host. All right, what kind of service is Canvas, where you're turning in your homework? That's software as a service. You can't change it. All you can do is use the options they give you. All right, so if you combine dissimilar computers, what have you got? That's grid computing. All right. So it's ops. That doesn't look like a real name. XC, I know who that is. And you have it. Good. All right. So let me stop this recording.